Hello, welcome to another Midnight Maths video. Today we'll be introducing the ideas of optimization so that we can do some concrete examples in later videos. So the main thing to talk about here are what's called extrema, and this is a fancy word for either a minimum or a maximum. So first we got to start off with local or relative extrema, and we'll compare those with absolute extrema later. And so basically, a local extrema is where the value of f, or whatever function you're optimizing at some point, is higher or lower than only its immediate neighbors. So let's look at this graph as an example and identify some of these. So here, right, you can see that this point is higher than its neighbors, right? You can zoom into its neighbors, and you can see that it's clearly higher than those, and so we say it's a local maximum, which I'll abbreviate like that. And down here, right, this point, which I'll do in a different color, you can see it's clearly lower than its neighbors, its immediate neighbors, and so we get a relative minimum. Note that the terms local and relative are basically, they mean the same thing in this context. But now the other type of extrema is called an absolute extrema, where the value is higher or lower than all values over some interval. Now the underlined portions here are really the difference, right? With local extrema, it's just comparing a very small circle around that point, while absolute extrema, you're looking at an entire interval, which may be unbounded, right? You might be looking at intervals like minus infinity to infinity, which is the whole number line, right? And so look at here, this interval happens to be bounded between some two points, right? Now this point is, we would call this an absolute extrema, right? Because in this interval where I've defined the function, right, it is the highest value. It's the highest value in this interval. So it's an absolute extrema. Down here, this would be also an absolute extrema. In this case, it would be an absolute minimum. And the above would be a maximum. And again, that point is the lowest point in the entire interval. And so it is an absolute minimum. And we can go on identifying some more of these points, right? These points are local minimums. And this one, we'll talk about this later when we talk about critical points. But just because it's not differentiable at this point, right? Still a local maximum right there, because it is still higher than its neighbors, as you can see. And we've got a local maximum here as well. Hopefully that's illustrated the point. The other quick thing that I'd want to mention is the concave up and down. It's really just a fancy word for whether the first derivative is positive or negative at that point, but I wanted to throw it in this video because we will be seeing this later in what's called the second derivative test. And yeah, that'll be it for this video. Future ones will be talking about actual optimization strategies, such as the first derivative test and the second derivative test and so on. And we'll also be doing some example problems in those videos. So with that being said, thank you for watching, and I'll see you guys in the next one.